Good day, everyone. Today we will talk about rational function. So we have subtopics under rational function such as rational equations, rational inequalities, and rational function itself. So first, let's talk about rational equations. When we say rational equation, it is an equation containing at least one fraction whose numerator and denominator are polynomials. Okay, take note it should have at least one fraction. Okay? And uh, on that fraction, the numerator should be polynomial and as well as the denominator. So example of rational equation, we have letter A, 1 over x plus 1 is equal to 2. Then letter B, 1 over x plus 1 plus x over x plus 2 is equal to 1. And letter C, x over x plus 1 is equal to 2 over x plus 1 minus 1. So in rational equation, there can be uh, one fraction on the left side or one fraction on the right side or to both sides. Okay. So in rational equation, we are looking for the specific value of x or the solution that will make the given rational equation true. Okay, so to make it possible, we have different steps. Okay, so here we have the steps for solving rational equation. First step is you have to find the LCD of all terms in equation. Then second step, you have to multiply both sides of the equation by the obtained LCD. Then solve the resulting equation. Then after that, you have to check um, if the given or if the obtained value of x will be or will make the rational equation true. Like for example, suppose we have this given rational equation 3 over x minus 1 half is equal to 12 over x. Okay, so to find the LCD, okay, get this denominator, we have x, then get this denominator, we have 2. Okay, therefore we have 2 times x or 2x. So this x, nakuha na natin siya kanina dito sa first denominator. So this will be our LCD, 2x. And to make it sure that this is the least common denominator, let's try to divide uh, it, if it is possible to divide this LCD and the denominators on our fraction on the given rational equation. So 2x divide x, that is possible. 2x divide 2, that is also possible. And 2x divide x is also possible. Now, let's proceed to the next step, which is you have to multiply both sides by the LCD. Okay, so as you can see on our right or left side of the equation, we have two terms here. Okay, the LCD, then here we have two terms. Therefore, we have to distribute the LCD to each term. Okay, so 2x times 3 is 6x. So 6x divide x is 6. Then 2x times 1 is 2x. So 2x divide 2 is x. That's why here we have 6 over or 6 minus x. Okay? Then on the right side, we have one term only. So 2x times 12 is 24x. Divided by x is 24. Okay? Then after that, we have to combine like terms. So this 6 will be transferred to the other side. Okay, so positive 6 will become negative 6. That's why 24 minus 6 is 18. Okay, so we will be having negative x is equal to 18. Okay, take note, we are looking for the value of x. Therefore, to make it positive, we have to divide or multiply both sides by negative 1. So, negative x divided by negative 1 is positive x. and 18 divided by negative 1 is negative 18. So, to make sure that this value of x is correct, let's check our answer. So to check, you have to substitute the obtained value of x to the original equation. So our original equation is 3 over x. So it will become 3 over negative 18 minus 1 half is equal to 12 over x will become 12 over negative 18. Okay? So you have to find the common denominator to solve the left um, side or the values on the left side, okay? So that the common denominator of negative 18 and 2 is 18, okay? So we will be having 18 as our denominator. So 18 divide negative 18 is negative 1 times 3 is negative 3. So the same as 3 over negative 18. Then 18 divided by 2 is 9 times 1 is 9. Okay? So just copy the right value. So simplify this. We have negative 3 minus 9 is negative 12 divided by 18. So we will obtain negative 12 over 18 is equal to negative 12 over 18. So that is true statement. In that case, the right solution is x is equal to negative 18. Okay? So our answer is x is equal to negative 18. Another example, we have 5x over x plus 1 is equal to 4 minus 5 over x plus 1. So again, first, find the LCD. So just get this denominator, that is our LCD. Then the denominator of 4 is 1, so we don't need to get that. And the denominator of this term is 1 as well, okay? I mean, x plus 1. So we don't need to repeat x plus 1. Therefore, our LCD is just x plus 1, okay? So multiply this LCD to both sides of the equation. So this is the step 2. We have to multiply. Let's try first the left side. As you can see, we can cancel out x plus 1. That's why we have 5x on the left side. Then on the right side, as you can see, this is two terms, okay? The values here we have 4 and 5 over x plus 1. So ibig sabihin, we have to distribute x plus 1 to each term of the expression, okay? So x plus 1 times 4 means you have to distribute 4 to x plus 1. So 4 times x is 4x. 4 times 1 is 4. Okay? Then on this term, we have x plus 1 on the denominator. That's why we can cancel x plus 1. So we will obtain 5. Okay? That's why here we have minus 5. Now, we have to combine similar terms. So this 4x will be transferred or transposed to the other side. It will become negative. So 5x minus 4x is x. Okay? Then 4 minus 5 is negative 1. Therefore, our value of x is negative 1. But to make sure if it will make this equation true, we have to check our obtained value of x. Okay? So we have to substitute x by negative 1. So this will be 5 times negative 1 is negative 5. Then negative 1 plus 1 is, again, negative 1 plus 1 is 0. Then this will be 4 minus 5. Then negative 1 plus 1 is 0 as well. As you can see, we have undefined here. Okay, so undefined and undefined. In that case, we cannot identify the exact value of this equation. In that case, x is equal to -1 is not a solution for this equation. Okay, so our final answer would be no solution. Okay, there is no value of x that will make this equation true. Okay, next, let's talk about rational inequalities. So in a rational equation, we have finite value of x. However, in rational inequalities, we have infinitely many solutions. Okay, we have more than two solutions. Okay, so infinite. So marami po. That's why for us to obtain the value of x, we have to have the interval and set notation to denote the possible solutions on the given inequality. Okay, so let's talk about the interval and set notation. So in interval notation, these are examples of interval notation. Okay, so we have a to b, or from a to b, wherein a is not included because we have parentheses, and b is not included as well because we have parentheses as well. Okay, same goes with this, a to b, but a is included and b is included because we have square bracket. Okay, so however, on this example, a to b, or the value of x is from a to b, wherein a is included because we have square bracket, and b is not included because we have parentheses. Okay, so in set notation, we have this form. It is read as x such that x is greater than a but less than b. Okay, greater than a, ibig sabihin, a is not included, and less than b, ibig sabihin, b is not included. Okay, so they are the same notation. Okay, so this is in interval notation and this is in set notation. But in graph, you will see this illustration from A to B, wherein A is not included and B is not included. It means that the only values of x here is the values between A and B. Okay? So here we have x such that x is greater than or equal to A but less than or equal to B. Okay, we have the word or equal to on our inequality, greater than or equal to, less than or equal to, therefore they are included. Okay, so in illustration or graph, we have this illustration from A to B, wherein the endpoint of our let's say segment, for instance, is closed circle or shaded circle. Okay, because it means that they are included, or the value with that point is included on our solution. Okay, unlike on our first graph, the endpoint is open circle or unshaded. Okay, to denote that they are not included. So here, letter A is included. That's why we have x such that x is greater than or equal to A but less than B. Okay, so in illustration, um, in A, we have a closed circle or shaded circle. Here, we have open circle or unshaded. Okay, because B is not included. Okay, then how about this one? From A to positive infinity. Okay, it means that the values of x is from that specific value a to positive numbers. Okay, so in set notation, we have x such that x is greater than a. Okay, so because we have positive values. Okay, so in illustration, we have this graph from a to positive infinity or to the right. Okay, wherein A is not included because we have closed, I mean open circle. Okay, so this one we have square bracket for A. So from A to positive infinity, it means A is included to the positive value of, or I mean possible value of x. So in set notation, that is x such that x is greater than or equal to A. Okay? So in illustration, we have closed circle A to the right. Okay? So however, suppose we have this example from negative infinity to b. So in set notation, that is x such that x is less than or equal to b. So here we have b, for instance, since b here is square bracket and here is less than or equal to, therefore here we have shaded circle. So from b to the left, since we have less than, okay? So it means, or this interval means, our possible values of x are the set of real numbers. Ibig sabihin yung lahat ng real numbers. So from negative infinity to positive infinity. So in set notation, that is x such that x is an element of real numbers. So in illustration, we have this illustration, okay? To denote that all the real numbers or all numbers on the number line are included on the possible solution. Okay, so like for example, suppose we have this interval. So x is greater than negative 2 but less than positive 2. What does it mean? It means that the possible value of x is between negative 2 to positive 2. Okay? Negative 2 is not included and positive 2 is not included because of our inequality symbol. There is no or equal to on our inequality. Okay? It is just less than. Okay? So interval, we have from negative 2 to positive from negative 2 to positive 2, wherein they are not included. That's why we will use parentheses, okay, instead of square bracket. Then in set notation, so x such that x is greater than negative 2 but less than positive 2. So in graph, we have this illustration. Suppose this is negative 2 and we have open circle to denote that it is not included. And here we have positive 2 and open circle to denote that it is not included. And we will shade this part between negative 2 and positive 2 to denote that these are the solutions for our inequality. Okay. Okay, let's solve the inequality. Suppose we have this given inequality, 2x over x plus 1 is greater than or equal to 1. Okay? So first, to solve for the inequality, you have to make it in general form. Okay? Or you have to convert it to general form. And to make it possible, you have to transfer or transpose this positive 1 to the other side. Then we will be having 0 to the other side. Okay? So for instance, so this is our given inequality. We have to transpose this 1 to the other side. It will become negative 1. So we will be having 2x over x plus 1 minus 1, then greater than or equal to 0. Okay? So to solve this, you have to find the LCD. Okay, since they are similar fraction. Okay, so we will obtain x plus 1 as our LCD. So x plus 1 divide x plus 1 is 1 times 2x is 2x. Okay? Then x plus 1 divide 1 is x plus 1 times negative 1 is negative 1 times x plus 1. So we will simplify this. 1 times or negative 1 times x plus 1. We will obtain negative x minus 1. So we have 2x minus x minus 1 over x plus 1. So simplify this, we have 2x minus x is x minus 1 divided by x plus 1 is greater than or equal to 0. So after you obtain this answer, you have to get the numerator and denominator and equate it to 0 to find the critical values. Okay, so the numerator is x minus 1, so equate it to 0. We have x minus 1 is equal to 0. Then solve for x. This negative 1 will be transposed to the other side. Therefore, x is equal to 1. The denominator is x plus 1. So this 1 will be transposed to the other side. That's why we have x is equal to negative 1. Okay? So, um, what are you going to do is you have to plot this obtained value of x or critical values to the numbered line. Okay, ipa-plot po natin sa number line. Pero, ito po yung number line. Ano po yung, dapat po tayo mag-decide if we will use shaded circle or unshaded circle to make it sure that we will use the correct circle on our number line. So, we have to evaluate the given inequality on our obtained critical values, okay? And if the statement is true, therefore, we will use the shaded circle. And if the statement is false, we will use the unshaded circle. So let's try x is equal to 1. So if this is, or if x will be substituted by 1, we have 2 times 1 is 2. 1 plus 1 is 2. Therefore, 2 over 2 is 1. So 1 is greater than or equal to 1. Therefore, that is true. So we will use okay, so since x is equal to negative 1, we'll make this equation or inequality true. We will use closed circle, okay? On the other hand, if x is equal to negative 1, as you can see, if we substitute x here on the denominator, it will become negative 1 plus 1 is 0. Okay, and it will make this inequality undefined. Okay, therefore, negative 1 is not included. Okay, okay. So, um, as you can see, our number line is divided into three parts. We have this part from negative infinity to negative 1, and this part from negative 1 to positive 1, and this part from 1 to positive infinity. So what are you going to do is you have to get one value that represent each part of the number line, okay? Then if the statement is true, therefore you have to get that part, and that is our possible solution or solution for the given inequality. Like for instance, so on this part, suppose I get negative 2, so x is equal to negative 2, then use the given inequality. We have to substitute x by negative 2. Therefore, we will obtain 2 times negative 2 over negative 2 plus 1 is greater than or equal to 1. So, simplify. 2 times negative 2 is negative 4 divided by negative 2 plus 1 is negative 1. So, negative 4 divided by negative 1 is positive 4. Okay, it should be positive 4. So positive 4 is greater than or equal to 1. That is true. Okay, so positive 4 is greater than or equal to 1 is true. So this is correct. Then on this part, let's say we will get 0. Okay, so substitute x on our given inequality. We have 2 times 0 divided by 0 plus 1 is greater than or equal to 1. So 2 times 0 is 0 over 1. Then 0 over 1 is 0. So 0 is greater than or equal to 1 is false. Okay, 1 is greater than 0. Therefore, it is not included on our solution. Then on this part, let's say we will get 2. So x is equal to 2. Therefore, we have 2 times 2 is 4. Then 2 plus 1 is 3. It's greater than or equal to 1. So 4 over 3 is approximately 1.333. So it is greater than or equal to 1. Okay, that is true. Therefore, this part is also included on our solution. That's why our illustration should be from negative infinity to negative 1. Okay, it should be shaded. Then from positive 1 to positive infinity. Okay, so shaded. Okay, that is our illustration. Then in interval notation, we will be having from negative infinity to negative 1. Okay, that is this part of the graph. Union. Okay, it should have union to denote that this part is also included from 1 to positive infinity. Okay, as you can see, we use parentheses here to denote that negative 1 is not included, and the square bracket here to denote that positive 1 is included. Okay, so again, to solve for inequality, we have to change this to general form. Okay, then after that, solve for the inequality. So we obtain this, then equate the numerator and denominator to 0. Okay, so we obtain the critical values, then plot them to the number line, but to decide whether you're going to use the shaded circle or open circle, you have to try them to the original inequality. So we, when we use 1 as our value of x, this will make the inequality true. Okay? On the other hand, negative 1 will make the inequality undefined. So, for 1, we use shaded circle, and for negative 1, we use open circle. Then after that, the number line is divided into parts, and you have to get a value on each part, okay, to test whether that part is included on the solution. So on this part, we use negative 2, and it will make our um, inequality true. So that is 4 is greater than or equal to 1. Okay. Then this part, we use 0, and it will make a false statement. So this is not included. And we use 2 on this part, and it will make, or it made a true statement. Therefore, this part is also included. Therefore, this part and this part, this part and this part are the solutions. Okay, so in interval, this is from negative infinity to negative 1, and this is from 1 to positive infinity. Okay, so we will use union. Then in set notation, it should be x such that x is greater than or equal to 1, but it should have x is less than negative 1. Okay, less than negative 1. So x such that x is greater than or equal to 1, and x is less than negative 1. Okay, so another example. Suppose we have this inequality, 3 divided by x minus 2 is less than 1 over x. Okay, so again, you have to make it in general form. So this x or 1 over x will be transposed to the other side. That's why we have 3 over x minus 2 minus 1 over x is less than 0. Okay, so we have 0 on the right side. So to solve this, you have to find the LCD, and the LCD is x minus 2 times x. Okay, so x times x minus 2. So let's try to solve. X times x minus 2 divide x minus 2 is x. Okay? Times 3 is 3x. Then x times x minus 2 divide x is x minus 2 times 1 is 1 times x minus 2. Okay? Then simplify this. We have, okay, copy 3x. So negative 1 times x is negative x. Negative 1 times negative 2 is positive 2 divided by x times x is x squared. Then x times negative 2 is negative 2x. Okay? So, simplify this. We have 3x minus x is 2x. Then copy 2 divided by x squared minus 2x. Okay? Then less than 0. Again, next step is you have to equate each or the numerator and the denominator by 0. So, here we have 2x minus 2 is equal to 0. And when we solve for x, that is 2x is equal to negative 2, divide both sides by 2, we have x is equal to negative 1. Okay? Then here, as you can see, this expression is same as x times x minus 2, right? So when we equate x by 0, we have x is equal to 0. Then when we equate x minus 2 to 0, we have x is equal to 2. That's why we have x is equal to 0 and 2. So we have three critical values, and those are negative 1, 0, and 2. Okay? To make sure that these values are included or not, let's try to equate them to our inequality. So let's try negative 1. Okay? So negative 1. So 3 over negative 1 minus 2 is negative 3. So 3 over negative 3 is negative 1. Okay? So here we have negative 1. So 1 over negative 1 is negative 1. So negative 1 is less than negative 1. That is false. Therefore, we will use open circle for negative 1. How about 0? Here, when we input 0, here we have 1 over 0 that is undefined. Therefore, that is already not included. Okay? And when we use 2, we have 1 over 2 here, so 1 half. Here we have 2 minus 2, that is 0. Therefore, undefined. Okay? 3 over 0. So, 2 is not included on our solution. Now, what have you noticed? The number line is divided into 4 parts. Okay, we have this part from negative infinity to negative 1, and this part from negative 1 to 0, this part from 0 to 2, and this part from 2 to positive infinity. Okay, again, next step po is get a value on each part. Then, if it is true, or if it will make a true statement, therefore that part is included. Okay? For instance, suppose on this part we get negative 2. Okay? So negative 2, use the given inequality, we have 3 over negative 2 minus 2 minus 1 over negative 2 is less than 0. Okay, so here we use this one, so that is the same. Um, when we simplify this, we have 3 over negative 4 minus 1 over negative 2, or we have positive 1 half since we have double negatives. Okay, then less than 0. Then when we simplify them, we have negative 0.25 is less than 0. That is true. Okay, 0 is greater than negative 0.25. So it means that this part is included on our solution. Then next, how about this part? Let's try to get negative zero point 0.5 for instance. Okay, so when we use negative zero point 0.5, we will be having, okay, so substitute x by negative zero point 0.5. Then simplify, we have 3 over negative 2.5 plus 1 over zero point 0.5 is less than 0, and our answer is 0.8 is less than 0. That is false statement. In that case, this part is not included. Okay? So next, we have x is equal to 1 for this part. Okay, then substitute x by 1. Okay, then simplify, we have 3 over negative 1 minus 1 over 1 is less than 0. So simplify, we have 3 over negative 1 is negative 3 minus 1 is negative 4 less than 0. This is true, right? Negative 4 is less than 0. Therefore, this part is included on our solution. Then next one, we have this part. Suppose we will get um, oh, I used 2 here, and it is our critical value. How about let's try 3? Okay, for instance, if our x is 3, we will be having, so this will be 3 minus 2 is 1, right? And here we have 3. So 1/3 here. Then here we have 3 over 1 is 3. So 3 is less than 1/3. That is false. Therefore, this part is not included. That's why our solution will be, okay, in graph, we have this illustration. Okay, this is the included part, and this is the included part, or they are the solutions. So in notation, we have interval notation from negative infinity to negative 1. Okay, this part wherein negative 1 is not included. That's why we use parenthesis. Union 0 to 2. Okay, wherein 0 and 2 are not included. That's why we use parentheses. Then in set notation, we will use x such that x is less than negative 1 and x is greater than 0 but less than 2. Okay? So that is for solving rational inequalities. For more examples, you can refer to your textbook, pages 60 to 63. Okay, let's have the domain and range of rational functions. So to find the domain, you have to equate the denominator to 0. Okay? Then after that, the obtained value of x will be the restricted value. It means that value is not included on the solution because it will make the denominator be equal to 0. So we have undefined. Okay? So when we are going to find the range, you have to solve for x. Then after that, you have to get the denominator as well and equate it to 0. Same with this process. Okay? So like for instance, find the domain and range of the function y is equal to 1 over x plus 3 minus 5. Again, to find the domain, get the denominator, so x plus 3, then equate to 0. We have x plus 3 is equal to 0. Then solve for x, we have x is equal to negative 3. Therefore, ito yung value na hindi dapat nakasama sa value ng x because mag-undefine yung ating denominator. Okay? Or ang ating rational function. In that case, our domain is from negative infinity to negative 3, wherein negative 3 is not included, union negative 3 to positive infinity. Okay? Or in set notation, we have x such that x is an element of real numbers, and x should not be equal to negative 3. Okay? So this will be our domain. Lahat ng value ng x except sa 3. Or I mean negative 3. Okay? Next is this one. The range. So to find the range again, solve for x first. So to make it possible, this term will be transposed to the other side, yung negative 5. So we will obtain y plus 5. Okay? Negative 5 will become positive. Is equal to 1 over x plus 3. Then after that, cross-multiply po natin ito, tsaka yon, then 1 and yung denominator nitong y plus 5, which is 1, di ba? So, y plus 5 times x plus 3 is y plus 5 times x plus 3. Then 1 times 1, yung denominator ng y plus 5, is 1. Okay? So, simplify natin to. We have y times x is xy, y times 3 is 3y, 5 times x is 5x, 5 times 3 is 15, is equal to 1. Then, since ang goal po natin dito is we have to solve for x, kailangan po nating um, i-isolate yung x variables dito sa left side. Then yung iba, ililipat po natin sa right side. So this xy will remain here. Then 3y will be transposed to the other side. It will become negative 3y. Okay? Then 5x will remain here. Then 15 will be transposed to the other side. It will become negative 15. So since we have here 1, 1 minus 15 is negative 14. That's why we obtained this equation. So after that, we have to solve for x, factor out the x, okay, or factor out this expression. So we have common here, and that is x, right? So our first factor is x. So to find the other factor, we have to divide this by x. So xy divide x is y. Then 5x divide x is 5. Okay? So we have x times y plus 5. Then copy the values on the right side. So to solve for x, you have to divide both sides by y plus 5. Okay? So y plus 5 divide y plus 5. Then we will cancel y plus 5 here. Therefore, we have x is equal to negative 3y minus 14 over y plus 5. Again, as I said earlier, para po mahanap yung range, i-equate po natin yung denominator sa 0. So, y plus 5 is equal to 0. Okay? Then, solve for y is equal to negative 5. Ibig sabihin po nito, ito po yung ating restricted value. Okay? Ibig sabihin, ang atin po magiging range ay any number or all real numbers except negative 5. So, in interval, we have the range is equal to negative infinity to negative 5 union negative 5 to positive infinity. And we use parentheses to denote that negative 5 is not included. In set notation, we have x such that x is an element of real numbers wherein x should not be equal to negative 5. Okay?